My name is Anil. I'm a principal software engineer in Lumina Networks. With me, I have Luis Gomez. He's a principal test engineer in Lumina Networks. So I build things, he breaks things. So that's why we are here together present this solution. It has a two half. First half is basically talking about the problem with the existing scale problem with OpenDaylight. And second half will be talking about the possible solution that at Lumina we are thinking of, and what all pieces can be worked upstream and what all we are doing locally. So to you, Luis.
Thank you. So thank you, everybody, to be here first, because, Friday, everybody has probably other things to do. So thank you very much for being this presentation. So who in the audience knows OpenDaylight, even if it is a little bit? OK, not bad. So I will explain very briefly the first part of the presentation, because it's going to be a little bit about how OpenDaylight is today and what are the issues. And then I will pass to my colleague, and he will explain more or less the ideas we have in our company, as well as in OpenDaylight, to improve the existing situation. All right, you can go ahead. So for those that are familiar, this is the OpenDaylight platform today. It has, obviously, for those that have been following the OpenDaylight, it has one thing to realize: it has much less project than we used to have like a few years back. The reason is clear, no? The thing has matured. Not all the applications are, very much consumed or relevant anymore. But whatever we have today in OpenDaylight is very, in my opinion, is very useful and relevant. So this is what it is. If you see the platform a little bit, it's like it's the typical controller kind of architecture where you have, the southbound is normally the plugins that talk to the different devices, whether it's physical or virtual. Then you have a middle layer, which is the abstraction layer, which is the very known NDSAL in OpenDaylight. It's a YAM-based abstraction. And then on top of that, you have the services that we currently have in OpenDaylight, and then plus you can obviously develop your own service in the platform. The northbound part of the OpenDaylight is normally REST, and then, RESTconf, to be more specific, is REST from YAM models. And then on top of that, you can also run your application, orchestration, whatever you have today. Any question, particularly on the architecture platform? Let's go ahead. So this is the typical kind of OpenDaylight application. Whether it's in OpenDaylight today or you are doing your own, it doesn't matter. The green box here is what you normally do, and it's a network service. This network service talks to this common component called LDSAL, and it has as a data store, and then they have a message broker for notification and RPCs. So yeah, and then on the southbound, you normally pick whatever plugin your network supports or to talk to the devices. On northbound is the system, the same northbound as everybody. You just have to deploy your YAM model, and then automatically you read the rest out of that. So this is just the architecture. Now, what can you do with this architecture today? All that you see here is runs in a JVM, so it runs in one process. And you can actually do vertical scaling. You want to scale, the first thing you're going to do, OK, how can I scale the existing architecture where you have a process, right? So the kind of things we can do, at least a few here. We do some of this with our customers, actually. So some could be just code optimization. No? You are a developer for the network service, so you can optimize your code to be more efficient. The NDSAL, the way you interact with NDSAL, it could be single transaction, multiple transaction in a single request, so we can do batching. You can do, it's Java, so you can do garbage collector kind of optimization. You can do more or less all the things that are here on the application level. But not only that, you can also optimize the way you interact with the devices. You can be less chatty, or you can try different techniques to be more efficient, like collecting less statistics if this is the reason why your controller is getting busy. Anyway, so whatever you do here is going to give you some performance scale thing, but you are always limited by your system, the system specs, whatever is running the JVM or the process. Any question on this one, by the way? I think it's very straightforward. Now, again, you have some kind of bottlenecks. Like if you start to put more things in the same process, in the same system, there are things that we already know because we have deployments like they are hitting, no? Like for instance, data store transaction. No? Our own broker system, there is a moment where everything that you want to do with the platform is limited by the system itself. The blocking REST communication. Obviously, if you are using REST, it's synchronous, it's very good, but it has its own limitation. It cannot really go beyond some limit, right? And then the number of device connection. This is also very popular. I mean, a single instance of OpenDaylight can support some devices, but the moment you put more devices and more devices, there is a limit there. There is a moment that doesn't hold anymore. And then the chattiness of the protocol, what I said before. So depending on the protocol you are running, you can optimize, but there is always really something. And then some of the protocol, like netconf, well, the moment it's not just one connection, you send something. I mean, you have to, the way this works is that we upload the model into the controller, the jump model from the device. So the more devices you have, especially when you have different models, that also occupies memory. So that has a size, and in the end, that doesn't really scale. So any question so far on any of these things? If not, I'm going to pass to my colleague. He's going to explain the second part, which is what are our ideas to fix the existing bottlenecks and the vertical scale.
Thank you, Luis. So as Luis mentioned, right, when it comes to vertically scaling, you are limited by your resources. So when you talk about 100 devices, you want to scale it to 150, probably vertically scale will work for you. You try to squeeze in a little bit more thing and it will work, right? But the problem statement for us is we basically looking for a scale where you connect to 1,000 devices till it goes to 100K devices. So it's a pretty large range, right? So this solution is, we're kind of working on with that in mind. Some of you who already worked on OpenDaylight try to scale it out. They might be having a different model to scale it out because their range go from 100 to 1,000 devices. And you can solve it in a multiple way. But what we are looking for is the range is 100K. It means we don't really have any option, but we need to horizontally scale the ODL so that we can support those kind of a number of devices. So the first thing we need to do here is, breaking the monolithic system. As of now, you see ODL inherently, the container itself is microservice-based architecture, but the point is all these components run into single JVM, right? So it's not truly a microservice when it comes to horizontal, scaling, but it gives us the benefit that you can choose your component and run it in separate VMs, right? So that actually gives us a benefit that we can break the ODL, this monolithic structure, easily without doing much of, work that you don't really have to say code changes or something. You just take different packages, run into different JVM. So breaking the monolithic is easy, but what to break is something comes to specific use case, customer, and their requirement. So what very high-level idea here is we're basically breaking two parts. One is a network service part, where your business logic runs, okay? And then you are breaking device plugins that actually manages, manages the devices. Now, when it comes to extending any network solution in a microservice way, there's two challenges, a northbound and a southbound. Because in general microservices, web-based application, you see the traffic from a northbound is heavy, you need to kind of manage it. And there is a stickiness required and all that. But when it comes to networking solution, these requests come from both the sides, right? Your northbound is kind of trying to configure the service. From a southbound, your devices are sending, events, alarms, all kind of thing. So it put one more kind of a challenge on us to kind of how to manage it. So first thing is, you break your monolithic architecture, you take out your network service out, device plugin out, and then once you kind of take it out, because previously they both were running together, so they are using general programming interfaces to talk, fine. Now you're breaking it out, it means they are going to talk over the network. It means you need a communication channel between them. That's where the message bus come into picture. I didn't put any specific name here for a message bus, but there are options like Kafka, RabbitMQ, when it comes to message bus, and there are point-to-point protocol also we are exploring, gRPC and 0MQ. So all these are options, kind of we are exploring currently to come up with, what best suits our traffic that our services are going to generate. But hopefully we'll give more detail, probably in the next ONS and probably a working demo of this thing. So message bus for a communication between them. Now, what it does is, because you broke device plugin out of your main controller part, it free up resources for services. So in general, in our experience, a 60% CPU is consumed by a device plugin. So you take it out, it means your service will get more CPUs. Okay, the number of transactions that you put into data store will reduce. So that will give you, outrightly 60% more resources, and your service can scale, right? And when it comes to device plugin, you break it. You don't put everything, all device plugin in the same thing. So what we did is we are breaking, let's say most of our use cases are around OpenFlow, NetConf, and BGP, PSAP. We are trying to break them in their own driver. So they will act like agents, totally separate their own scope. The container is their own scope. So no two plugins running together, because we want to horizontally scale, so this separation is required. What it changes from a device plugin side of it and overall end-to-end interaction is, previously your services were writing data to data store, your plugin were reading from data store, and then it's pushing the configuration down to the devices, right? Now, because you broke your business logic out of device plugin, what happens now is your services write into MD cell, which is a data store, and then you have a shim layer that listens, that put the data into message bus, and then again it goes to the respective agent, and then it's written into their data store, and that's how the plugin again pick it up and write it down. So this is a very high level thing. Internally, there are a lot of optimization in how the message bus shim layer is being implemented, and all those, there are details in there, but this is the high level interaction that changes. So service data store to device plugin, it goes to service data store message bus to again data store and to the device plugin. Okay, so separation happened. So you basically converted it from a monolithic to microservice, but there is no scale, okay? Everybody, device plugin will get some more CPU, services will get some more CPU, but that's not, we just get to scale, probably 50% more, but that's not really going to help us for the scale that we are looking for. So what you do is now, it comes to individual scales. So on a southbound side, you have multiple of these device agent running that is managing your devices. So you horizontally scale it. You spawn multiple instances of this device agent so they can handle more devices. And then, because you broke out the device plugin, they need to talk to services, because services rely on these device plugin and what devices they are managing, right? So all these device agents are going to have their own life cycle, and they are going to advertise themselves through message bus to services that I'm the agent, I'm managing these kind of devices, whether this device is connected from me, disconnected from me. It all, those life cycle events are going to be there. It will differ based on what kind of a southbound, plugin you are working with, whether it's OpenFlow or a NetConf. And one important thing that we kept in mind is, because if you go for a horizontal scale, and if you look at your eventual architecture, your southbound side is going to be more crowded. It means you will have to spawn multiple instances there, right? And if you want to easily manage those agent, you need to make sure they are stateless as much as possible. So they are not retaining any data. They can retain the data, but once a restart happens, they should not be relying on that data. So if you make them stateless, that's going to make your life much easier to kind of manage these southbound device agents. And then configuration, because devices are connected, these are managing these devices. Now, network service need to configure these devices. So obviously, that communication, again, will go through the message bus. Now, fine. We established the same connection, same communication pattern with the southbound scaling, right? But the next problem comes is, okay, you spawn these many instances. Some devices are managed by someone. Who the hell is going to take care of that? How service will know that I want to configure device X, but who is managing that? Because they need to talk to the agent, right? So that's the next question that is imposed on this architecture.
I think there is some question already there.
Sure. They can have their own local data store, because what we are trying to do is we don't really want to, our communication is still going through MD cell, but it's going to be very local to that particular agent and the device is handling. So this MD cell data store is not shared. They're very local to just store their data and Yang model, because most of these plugins rely on those Yang models. So you need a data store to kind of put in there. Mm-hmm. So it's for our requirement in terms of data communication is we want to go for very async kind of a communication. There is no real time in the sense, yeah, we need that response should come from message bus, but our entire system is very async system. You kind of send the message to the message bus, it will go to the agent, and they will configure it, and they will respond back that this particular resource or device is configured. So that kind of a modeling we are using it here. But yeah, there is a timeout and a parameters that we are looking into, and what kind of traffic these are going to generate is going to impact. But the message bus here we are using it's just for a service communication purposes. Not really that the device agent started generating some alarm. We don't really want to feed back to the service thing. We are going to have a separate system where we are going to push it there, and then interaction will happen. So it's very high level. There are a lot of detail into it, but we probably can take this offline if you want to go for a more detail into it. Mm-hmm. Yeah, I'll answer that next, right? So this is the management part of it, right? One agent goes down, what are you going to do about it, right? And some of this answer is going to be probably in the last slide. But yeah, we have a thing in place for workload management, all these things, right? Well, first thing, how you figure out who is managing device, that's the first question itself, right? So what we did is the concept of device mapper. What it does is, whenever these agents basically come up, they advertise themselves. Then I'm an agent. I'm agent of this type, and I can manage devices of this type. Then the device mapper, that actually also sits in a message bus, and they actually register all the agents, saying, okay, I have an agent running, and that can manage, let's say, OpenFlow device or netcon devices, right? So once that happens, that can also do a work distribution and all that, because that inventory need to be populated in there. But the concept here is this guy know what agents are running. It also contains the information of which agent is mapping to what device is basically maintaining it. So it's going to be a centralized place where anybody can query and see, I want to see where this device is, and it can give you the agent ID to whom you can reach out. And then the agent ID can be very simplistic architecture. It can be your IP address to reach out to that agent, right? Or it can be any UUID that uniquely generate for each agent. So that solves the problem. Now, the workload management, right? Because how you know that how many devices this particular agent is going to manage, you can pose static policies there saying, okay, if it's netconf, I don't really want to, this agent to handle more than 50 devices. Or it's OpenFlow plugin, you will say 100 devices or less. Static policy you can apply. You can apply the dynamic policies. Dynamic policies in the sense, let's assume there is a way to figure out the CPU, memory, and the network load on this particular agent. If that can be feedback back to your device mapper, it can decide dynamically that whether you want to allow this agent to again manage one more device or not, right? So you can impose those kind of dynamic policies as well in this device mapper. Now, once the mapping happens, the next question will be that mapping is a data, service is a data, right? So there is a lot of user intent in being generated, so the data need to be persisted somewhere, right? Because if the entire system goes down, if you want to recover it, then you need that data, right? So for that, we are kind of introducing an external data store here. Because if you see here, we are not using clustering anywhere in this because it has other implication. It's not going to help in horizontally scaling here. So all these are running their local data stores. So if, let's say, this one instance goes down and the data is wiped, you don't have any data to recover, right? So for that purpose, we have an external data store. Now, this external data store, there's two work bins. There's two ways you can do it, right? So one of them is basically we're talking about hooking this external data store directly to your MD cell. So whenever the data is being written, it will go to the external data store, right? And there is already project going on. We call it alternate data store, and we are exploring multiple, hook like MongoDB, or for that matter, any other data store you want to hook in, you can do like etcd. So that work is currently going on. What else? Let me see if I'm missing anything here. And obviously, when you have this external data store and any of these services goes down or your agent goes down, they should have that business logic or that functionality in it that they know that once we come up, where to reach out and what data need to be extracted from a data store to kind of come back to the proper state of it, right? So that is something logic need to be in your plugins or in your service that need to be implemented. So once that happens, fine, you store the data, you horizontally scale the southbound, but when southbound increases, there is an intention because user want to manage bigger network, right? It means the northbound traffic will also increase because they are going to configure more services from a northbound side of it. So that is something you also need to kind of scale. Now, northbound scaling is a little bit trivial, is not trivial as is like, southbound part of it, because services are based on what kind of a service you are implementing. We have services where you don't really worry about, you just put a load balancer and you install, run multiple instances of these services, and your request can go to any of these services, it will work for you, right? So it's the easiest possible scenario you can think of. But there is a possibility where, you have two services, they are dependent on each other, then depend on your service, the northbound might get complex, right? But most of in our scenario, we have services that is where you can do very clear partition, and you can spawn multiple instances of those, and then you can put a gateway before them, or a load balancer that can load balance the request between these multiple instances on the northbound side of it. Again, these services need to be reconciliation aware. It means they goes down, they comes back up, they know where the data store is, and they can fetch their configuration and reconcile themselves. So most of our applications are written in that way. So it's an inherent benefit for us that just separating it out works good. It's just that we need to hook the database, and services need to know the database. So okay, that's fine. Everything is fine. But in the title it says container also, and I didn't talk about container yet. So what we are doing is, from a monolithic architecture, we are going to say the 100K device is going to support. If that is our target, it means the architecture that I've shown you, that will end up creating 300 to 400 instances for us, right? And managing one instance is, you see if the people from operations team, they know how hard it is. So managing 300 to 400 instances is going to be a nightmare, right? So, so what we say is we need a lightweighted vehicle to kind of run it. And that's where, after doing a lot of exercise, it's like we were thinking, how about VM and their provisioning? And there were a lot of use cases that's not going to work. And the ideal solution we came up with, like, we probably have to go to containers way, and that's what we decided. So you choose containers. Fine, you choose containers, but running the code in a container is not going to solve your problem, right? It's just a vessel there which we are running some code, and that's it. But it's not solving problem, because you run 400 containers, then again the problem comes of orchestrating all of those containers and how you're going to manage those containers, right? That's the next question. And it's one of the questions, right? So look at this side. It's like 1 to 100 instances you can spawn for netcon, 1 to 100 for OpenFlow, and then 50 instances of a service. Then they all are talking to data store, and then you have a message bus. So all these components can fail the system, right? So, and then we don't really want to write our own orchestrator outside monitoring all those things and whenever they're going down. And so hopefully you're getting my clues where I'm going with that, right? Apart from that, these are the questions that we need to answer, How these huge number of agents will be managed, how dynamic need of managing more devices will be handled. It's like initially you can start with some capacity, but then your number of devices increases. You need to increase the number of agents, and then your service instances might need to be increased. So these dynamic need is something you need to take care of. System will be deployed without spending a week on it, and you don't really want that customer go and say you install it. It's going to take us 7 days or probably a month, depending on what your architecture you're giving. So we want it to be easily installable. Single controller instance is hard to debug when it comes to OpenDaylight, and when you go into MDCell and those kind of error messages, whoever debug, they probably know the pain. So now you're kind of saying now there are 300 ODLs are running in there. How are you going to manage that, right? If the service fail at one point and some device throw up error saying, I'm not going to configure this configuration, how are you going to debug it end to end? So these kind of challenges will come, and this is going to be this seems like obvious thing, but this is the maker or breaker of whether a customer will take your solution or not. Because if the system is not easily debuggable or manageable, that's not going to fly. And then there are failure events like your device plugin is gone, your service is gone, your container itself is gone, the container running on a system is gone, your message bus is gone, all kind of a failure that you need to take care of. Now, how these failure event will be detected, the container goes down, how service will know that my agent is gone, and all those kind of scenario also need to handle. user want to, because the system is running, as a big system is running, you need to check the health, you need to check the health of service and all the agents and the entire deployment. And user need to collect from, the lot of debugging things, because something fails, what customer will do? You can't really go and tell them that, okay, on this service instance, give me log file from this agent, give me log file for this, and then I'm going to debug it. So you need some automated way to either access the data of the entire system or some way to collect it. And yeah, because it's been a while and people put deployment of ODL in their production. Now, next question is that, okay, you came up with a fancy architecture, fine. When it comes to operations, how we are going to migrate to this structure, right? Because if the migration is not smooth, this means you are basically saying my production is going to hit the outage here, right? Not a very good position to be in. There's some more. It's like how you're going to test this entire structure. So these are questions, and this is very it's like it's a big list, but there are more questions to it when you go into more deeper detail into it, right? So now probably I'll stop here, and that's my last slide. But because these answers, if you want to give me, I can't cover it in 30 minutes. It's a scale problem. It takes years to kind of solve it. So what we are doing here is we basically rely on a Kubernetes as our orchestrator engine. We are relying on some of the services that is provided by Kubernetes for container management. We are writing some of the code that is extension being provided by Kubernetes to figure out if the container goes down, any service goes down into it. And then you see Fluentd, Elasticsearch, and Kibana. That is the framework we are planning to use for logging purposes. So it can go and fetch logs from all these containers and push it to Elasticsearch. And you can use Kibana to go through those log messages. Obviously, we are doing some specific formatting for our log internally, so that it's easy for a user to go and look at these logs and dig through the log. We are using Prometheus and Grafana for monitoring all of these. Apart from that, we are using some of the Kubernetes health check and readiness APIs as well, with some of our extension into it to kind of figure out the health of individual services and the overall system. And then when the entire package is being done using Helm, so is something, because this is very common structure we are using, and we have a variety of southbound and the variety of a northbound, right? And we want to package in a way that a specific use case can be packaged, so we are using Helm there to kind of do the entire packaging here. Now, there's a big architecture, there's a lot of work, and you see that we are trying to leverage, because at Illumina we want to use most of the open source capabilities, right? And we want to explore all the open source options. And if you see all these projects under CNCF, so we want to leverage that open source power to kind of come to this scale. Obviously, there are challenges in terms of stability and all those, but that's the life in open source, right? Now, the question comes is, okay, that's fine, you're trying to scale it, but what work you're going to do in OpenDaylight? So there are 4 tracks that we are mostly focusing, and some of these are already work in progress if you have joined the DDF or some of the conference session. One is the message bus shim layer. We're looking at the various options, like there is a already existing project called JSON RPC that can be used and defined as generic message bus interface. We can add the extension to MDCell itself to kind of interact with various kind of a message bus implementation. Or you can define a framework that application directly consume without hooking into MDCell and directly use it. Very simple interfaces for them. So these are the options that we are currently exploring. Probably we will narrow down to one and go that way. And hopefully we'll share more detail in next ONS. External data store support, as I mentioned, alternate data store is a project that is already going on that actually directly hook into MDCell. And then we are looking for, there's one way is to keep the existing LabelDB data store, but hook the additional one. The other option is that LabelDB can itself be replaced by any other enterprise level database. So that implementation can be done. So these are the 2 options. Device mapper service is a very generic service. So this is something, although we are implementing internally, but there is a good likelihood that this is something we can share with the community back, because there is nothing. The only context is you basically do the workload balancing between your agents and devices. So that's pretty generic component we probably will do. Optimizing OpenDaylight boot up time. So everybody who actually work with container, you see that the container life cycle is very fast, and you assume that microservices basically come back fast, right? If it goes down. Currently, ODL probably take, 90 seconds to come up. So we are trying to reduce that time, and that's going to be more critical for the failure scenarios where your services goes down and come back up. So these are possible work items which we are going to upstream. Now, apart from this, because we have shown a lot of other architecture component, whether we are going to, do any other work upstream or not. But when it comes to, microservice architecture, everybody has their own taste and the way they want to horizontally scale in and what options they want to keep it. We want to probably give a more detailed reference architecture to the community. We will share some of the generic component we are going to share. But when it comes to, entire package, that depends on each organization, what tools they are using, what existing software they have, what kind of skills they have, right? So it's very hard to come up with very generic kind of implementation of it. Reference architecture you obviously can come up with. So we'll see what all can be done, but definitely we are going to share the reference architecture that we are going to use. So yeah, that's pretty much it, I think. Yeah, just reach out to us anytime if you have any questions. We are on IRC and OpenDaylight mailing list, or these are our mail address. You can reach out to us. So let's see how much time we have. So I think we don't have a time, but I think I can take 1 or 2 questions here.
Do you have any upstream branches now if you have to start a project?
So this exercise is mostly internal, but some of the other projects is something you will find some of the work, like I mentioned in the previous slide, right? Some of this discussion is up there, and we are currently actively discussing. If you go to wiki page of OpenDaylight, you will find some other details there.
So which one you are more interested, like from all this message bus database or anything else you're looking?
Yeah, some framework or like how we can scale it from netcom side or containerization part.
No, this work is mostly internal to us because more are deploying and how you want to structure the entire architecture, right? So there is no generic part that we are doing, but it's just a message bus interaction. These are the common components that we can do for OpenDaylight. Because this problem is not you can solve within OpenDaylight. You have to go up and see the OpenDaylight and as a service, and you have to solve it, right? So this is mostly internal, but yeah, these components are something we are working upstream to kind of, work with that. Yeah. Okay, guys, thank you. I think I'm 3 minutes over, but we can always talk offline. So.